Excuse me, sir.
What's up?
If I give you $20, can you solve this problem?
Is this right?
It's incorrect. If I give you $20, can you solve this problem?
I have no idea.
Okay, I'll take that $20, sir. Thank you very much. It seems like nobody can solve this problem. Let me show you how to solve it. F of x equals x over root x squared plus 4. So first, we're going to look at for the domain. The domain of this function would be found in the denominator, but since the denominator has a square root, it will never equal 0. So that means the domain is all real numbers. Now we're going to look for vertical asymptotes. The asymptotes are also found in the domain, but since the domain never equals 0, there's also no vertical asymptotes. And then for horizontal asymptotes, we can be found that this it's going to be the leading coefficient here and the leading coefficient here, which is going to be x over root x, but that's going to be x over absolute value of x because you have to do that. So then that would be 1 over 1 and negative x over absolute value of x, which would be 1 over negative 1. So that means we have a horizontal asymptote at negative 1 and we have a horizontal asymptote at 1. The reason we found the derivative was to find the critical numbers. But since there's no x value in the numerator, in this equation, there are no critical numbers. But on this one, we do have a critical number, and that is going to be negative 12x, which is going to give you x equals 0. So now, since it is a critical number, and it is f double prime, you're going to have an inflection point. And this is, an inflection point here is going to be 0, and then you're going to plug 0 back into the original function, and that's just going to give you 0, because it's going to be 0 over 4, and that's 0. And then here, since it's positive, you're going to have concave up, so you're going to have a minimum, and you're going to have concave down, and you're going to have a maximum. With the asymptotes at 1 and negative 1, that means that this line going to infinity can never cross that line, but it'll get ever so close infinitesimally. So, with this here, we have the asymptotes. From 0 to infinity, negative infinity, it's going to be always positive, so that's why we show that here. And from 0 to infinity, it's going to be negative. So that shows here. That wasn't so hard. I'll keep my $20.